In our third volume video, we will be reviewing setting up and running the volumetric analysis point cloud task. In our previous video, we reviewed using the tow extractor to define our stockpile tow extents, and we'll be using those in the volumetric analysis point cloud task. So to start off with, click on, just like we created the tow extractor point cloud task in the previous video, we've chosen the point cloud task tab. We're going to choose the gear icon in the top right, choose add in the top left in the point cloud task manager, choose volumetric analysis. Again, I'm just going to make the task name just the same as the task type label. Click OK. Alright, so I'm choosing the volumetric analysis point cloud task from the drop down. By default, the 3D polygon boundary option is going to be tool geometry, and basically that means that with the feature edit toolbar feature selector, this green arrow icon, essentially if that's highlighted, then I can select specific features to run the point cloud task on. So I can just choose this and run by feature layer over here on the right. I can also choose just to run on the feature that I've selected. For this example, we're going to change the setting here. We also have the ability to run by shape layer, which basically means shape layers that are in a table of contents. We can choose from those to run the volumetric analysis point cloud task on, because in the previous video we used the tow extractor to create that shapefile, and that shapefile is in our table of contents. We can choose that. That's what we're about to choose. You can also choose by file here. So even files that you haven't loaded into your project that aren't in your table of contents, you can choose to run the point cloud task on those. So I'm going to choose shape layer, tow. We're going to close this. Surface generation method, more than likely you're going to be using polygon only. And you can do some break line enforcement here too if you wanted to. Let's choose the whole tab. We want to use the base polygon as the boundary of the volume that we're trying to calculate. For surface generation method, we're going to be using LAS points. It's going to be on our active LAS layer. If you have multiple LAS layers, you could choose a different LAS layer here. Source points, if we've done any classification, we just want to make sure that the source points we're using correspond with the points that are in the stockpile boundary. So for example, if there had been some vegetation that we had classified on the edge of the stockpile or conveyor belt, we want to make sure we didn't choose those source points to run our volume on. So let's click on source points here. More than likely, if you're just trying to do simple volumes and you didn't have to do any classification, you wouldn't have to mess with this. But let's say we classified a conveyor or vegetation out. We're going to choose that create never classified option. Let's say if you've gone ahead and classified ground, you have your ground set, you want to run your volumes on that, you could choose that here as well. But for this example, we'll choose create never classified. Click OK. Break line enforcement. So if we had done some, it looks like there's some vegetation on the edge here that we didn't classify out. Just going to toggle the LAS display on and off. Let's say I classified that out, and this was the the void here that I classified out was basically making a false point cloud kind of ramp up onto the stockpile. You can use a break line to properly define that stockpile, and we're going to be going over using break lines in another video. So that's where you would use that potentially. Volume. For a simple stockpile, you're just going to want to use cut. Cut minus fill is commonly used as well. When we're doing bar pit analysis, we're going to be using the cut minus fill option. So let's say you had a drainage pond or something like that. You wanted to see the volume of a depression in the ground. You would just use fill. You want to see what the fill is, not the cut. The cut is basically the measuring the difference or the area above that stockpile toe that is a point cloud. So and then that's the point cloud surface is going to be the stockpile. So that's what we want to do. You can change the output volume whatever unit you like, feet, yards, or meters. Commonly use yards. You can add additional output attributes here. If your cut should be the volume number that we're getting should equal the same as cut. Sometimes I'll choose some of these just to make sure that ran properly, that I didn't have a fill or cut value or any other diagnostic attribute that looked out of line. But for this example, we're just going to leave those unchecked. Let's click on the output polygon file option. Again, just like the previous video, we're going to choose LP360 project path. Let me go to file here, show this one more time. Project settings. This is our project path. This is where the last data came from. So we're basically creating a folder here in this the AJAX2 folder called we're going to call it volumes or volume. Then do a /, and then we'll create our shapefile name. Just call it volumes. Dot, and just remember to put a .shp at the end. Unlike the toe extractor point cloud task, I'm going to have this set to overwrite. Let's say I'm not happy with some of the volumes that I got. I set up my volumetric analysis point cloud task incorrectly. I may just want to overwrite all those volumes once I've made whatever changes I needed to make. So we'll just have it set to that for now. And just remember, if you have this set to a pin and you ran this over and over again, you may be running the volumetric analysis multiple times in the same stockpile, so just keep that in mind. Let's go ahead and close this. We're going to click apply. And now we have the option, because we chose the shape layer, to run by project. So it's going to run for that whole shape layer. Let's go ahead and click on that. We're going to choose just confirming that's what I want to do. I'm going to say yes. We just have those 3 stockpiles, so this should go pretty quickly. Okay, let's click on our table of contents tab. You can see that volume file we created. I'm going to right click on that, go to feature analyst, and you can see our volumetric analysis numbers for those stockpiles.